In this short video, I'm going to go over the last 5 slides of section 2.4, which is on empirical rule, okay? So we just talked about how to find standard deviation in our class and how to use StatCrunch or the formula to find them. So the empirical rule is, well, the first application of how we're going to use it. So it's called 68, 95, 99.7 rule also, and it has to do with a normal curve, okay? So I'll show you a good picture very soon. It says for data with the symmetric bell-shaped distribution. I gotta show you a picture for this. Okay, maybe I'll read the word first. Bell-shaped distribution. The standard deviation has the following characteristics. Okay, first characteristic has to do with that first number 68. Look, about 68% of the data lie within one standard deviation of the mean. Doesn't really make much sense right now because I'm just reading it, but I'll show you a picture. I'll actually draw a picture myself and show you what they mean. Now I'll do an application problem, okay? Now let's move on to the next number, 95. About 95% of the data lie within 2 standard deviations of the mean. So guess what the last sentence will be? Okay, it has to do with 99.7, right? So about 99.7% of the data lie within 3 standard deviations of the mean. Now think about this. That's almost everybody, right? 99.7. So if you are not with this 99.7%, you are in this very small percentage, less than 1%, right? So if you are outside this 3 standard deviation points, you are an outlier. So we'll talk about this and how to identify outlier using standard deviation and z-scores in section 2.5. But all right, hopefully this is an example. Look, that is that bell-shaped symmetric curve they were talking about, okay? Now on this curve, we have a center in the middle. That's the mean, okay? That's the mean, x bar right in the middle. And if you go 1 to the right and 1 to the left, you will be 1 standard deviation above or below the mean. So remember that first characteristic that we read. There are 68% of the data, or 68% of the area will be in this blue region, okay? Okay, but if you go out, 1, 2 to the right, and 1, 2 to the left from the mean, you will be 2 away from the average, okay? 2 standard deviations above or below the average. So remember that second characteristic. If from like this point right there, all the way to this point right there, so yellow plus blue plus blue plus yellow, those 4 pieces together will be worth 95% of the area or the data, okay? So this middle area will be 95%. Now, 95 is what we call usual. Unusual will be like outside that 2%, but they're not so unusual. We don't call them outlier just yet. But now let's go out even further, okay? If you go 3 to the right and 3 to the left, whack, I'm sorry about that. I opened way too many animations up. So 3 to the right and 3 to the left, and this S is the standard deviation of how many you're going to the right. So 3 to the right and 3 to the left. Now the turquoise, yellow, blue, and blue, yellow, and turquoise, all those pieces add up to 99.7%, okay? So if you are in this turquoise, yellow, blue, blue, yellow, turquoise area, then you're not an outlier, okay? Because you're with the 99.7% of the data. But if you are outside that 3 standard deviation point, that's how you can identify that something is an outlier, okay? Well, these are 2 different things. To be considered an outlier, that's being very extreme. The other part is to be considered unusual, okay? I think there's another part coming up, so maybe I can just talk about those then. But to be considered outlier, you are outside this 3 standard deviation point. To be considered unusual, you are outside this 2 standard deviation points, okay? I think, don't worry though, this is probably coming back up again in later sections, okay? So look, blue and blue, these two blues together make 68%. But now, you know this is a symmetric distribution. So left blue piece and this right blue piece, they're exactly the same. So that's how they can figure out each pieces are 34 because 68 divided by 2 is 34 each. Now look, from here to there, they are 95% of the area or data. Now, how did they get this 13.5? Well, the first thing they did was they know the entire thing is 95. So they did 95 take away 68. Okay, if you do 95 take away 68, then you will get what these yellows are worth. But they're 2 equal pieces of yellow. So you divide that by 2. That's how you get 13.5. Open note, right? So when you're doing your homework or your test, if you need to go back to this slide to look at these exact numbers, that's okay, okay? All right, let's go to find the areas of these turquoise areas. So the whole thing from this turquoise end to the other end, that's within 3 standard deviation, that makes 99.7%, right? So how did they find this 2.35? Well, they did 99.7 minus 95. That's how they got these 2 turquoise area, and then they just divided by 2. Car going off outside. But this is the empirical rule, and we're going to use some, we're going to have some application problems that we can use this rule to solve, okay? So, all right, let me go to the next slide. All right, look at this for me, using the empirical rule. In a survey conducted by the National Center for Health Statistics, the sample mean height of women in the United States, ages 20 to 29. See, I was trying to apply myself into this, but I think I'm outside the age group, so I don't think I can, because, you know, that's the sample. So I shouldn't say the sample can represent women of all ages. So, but they just looked at these people. But then the average was 64.2 inches with the standard deviation of 2.9 inches. I'm going to go ahead and show you how to sketch a curve real quick, okay? In order for me to do that, I'm going to go and grab an iPad from my son. So I'll stop the recording real quick. I will be right back. All right, hold on. I'm going to go ahead and type. One more second. All right. So I'm going to open up my tablet so that I can do the work. I can sketch the work, okay? So I'll open up a blank piece of paper. So what they told me is that the mean is, I'll write these down real quick so that I don't have to go from one screen to another. So the mean is, 64.2 and standard deviation is 2.9. That is all I need to know for right now to sketch a curve, okay? So when I sketch a bell curve, I'm just gonna draw a horizontal axis here and a bell curve. Oh, I'm not so good at drawing a perfect bell curve, but let me try it at least, okay? Give me 1 second. So that looks good, right? That looks good. Okay, so right in the middle, I will put my 64.2. That's the mean, right? Now I need to go 1 to the right. I need to go 1 to the right. And I actually need to go 1, 2, 3 to the right. And I need to go 1, 2, 3 to the left, okay? In order for me to do that, I will need to add or subtract that standard deviation. So look at me, I opened up a calculator. And what I'm gonna do is, notice the mean is 64.2. I will add the standard deviation of 2.9 plus 2.9 equals 67.1. So that's how you go make your number line using the standard deviation. Now, I need to add another 2.9 plus another 2.9. So that's 70 here. And I do another 2.9. So 72.9. So when do you stop? You just need 1, 2, 3 to the right, 1 standard deviation. I'm sorry, let me do plus 1 standard deviation, plus 2 standard deviation, and this was plus 3 standard deviation. So I went 1, 2, 3 to the right, and I need to go 3 to the left. So go back to the middle, 64.2, and I'm going to subtract 2.9. So that's 61.3. Subtract another 2.9. 58.4, and last number minus another 2.9, and that's 55.5. All right, I'm done making my number line. Okay, so you add 3 to the right, you subtract 3 to the left. That's how you make your curve. Okay, now what they were talking about was this. Look, from 1 standard deviation for point from there to there, how much do we have? We have 68%. So I'll color it even. Okay, what color? I'll do red color. All right, hold on. So in this red area, I'm having too much fun with my colors today. All right, I have 68%. Okay, using the empirical rule because that's plus 1 standard deviation. And this is minus 1 standard deviation. So within 1 standard deviation, I have 68%. Is that the answer they wanted? In between 61.3 and 67.1? I don't know. Let me see. No, they wanted 58.4. Okay, so I need to go down further. So if I go down further, hold on. You know what? I have a good idea. How about I just cut it all up like the other picture they gave me, right? So this is 34. Hey, I don't want a dotted line. I think you know what I'm trying to do. This is 34%, right? Because that's half of 68. And this is 34%, right? All right, let's go out further. Let's go out further. Let me do another line. So how much is from this to there? Like, I think I want to just copy the numbers here real quick. So to the left of 34, that's where we have 13.5%. So this is 13.5%. So if that piece is 13.5, the piece to the right is also 13.5. And how about to the right of it? See, I won't say I'm cheating. I'm just being resourceful. I'm using these numbers. All right, so this one right there is 2.35%. And this is 2.35%. All right, so what did they want in this problem? So I got the curve ready. Mine is all marked up. They wanted height between, and I'll write that down, between 58.4, oopsie, and 64.2. So what percent? Estimate the percent of woman in between these two numbers. So I'll find those numbers in my number line here, okay? I like orange. So 58.4 is right here. And from here to how far? 64.2. Oh, you know what? It's just this one and this one together. All right. So how would you find the answer? I see it because my picture is so perfect. I can see the answer is going to be 13.5% plus 34%. So that's going to be 13.5 plus 34 equals 47.5%. So that's how you can do an empirical rule problem. I don't really memorize all these numbers. And honestly, there's another better method called normal CDF when we get to continuous distribution in the next unit. So for right now, I hope you see some basic problems. And this, 34, 13.5, 2.35. If you want to use that, use it to do your homework problems. But I think the answer is 47.5. So let me go and see. Let's see. Did they do it right? So they got this curve just like us. I think their number is a little more accurate. They got more decimal places, but they're similar to what I have. I have 34 and 13.5, 34 and 13.5. That's pretty good. And then what was their final answer? Is 47.72. My answer was 47.5. So I don't know why they gave us these decimals on this slide and use slightly different numbers over here. But you know what? Our answers are very, very close. So, this is how I would do this. The answer is 47.5%. So we can say about 47.5% of women are between 58.4 and 64.2 inches tall. I wonder if this was recording okay. All right, let me stop the recording now because I'm